Today, we're going to talk about the quadratic formula, part 1, section 5.6 here. We're going to talk about the quadratic formula. We're going to talk about real solutions today, and then we'll actually pick up and talk about imaginary solutions next week. So, the quadratic formula, section 5.6, we'll do part 1 of this today. Now, is anybody familiar with quadratic formula? Did some in Algebra 1 possibly? I know Sean said he did some. Anybody else? You did it last year? So you recalled it a little bit. Good. Sage, you did it last year, yeah. Okay. Quadratic formula can be kind of messy. It's kind of long, a little bit messy. The quadratic formula is this thing right here, actually. Quadratic formula is a quadratic equation written in standard form, ax squared plus bx plus c equals 0. And it can be solved with the quadratic formula. Now, this is the quadratic formula. I also have it written up on my board up there to the left. Okay, if you look up there to the left, it is up there. We will be using that again today. Now again, each of these come from the points A, B, and C. A is what's the quadratic term, B is the linear term, C is my constant term. Now this is what I call plug and chug. Because really what you do is you plug in your values for A, B, and C, and you chug through to simplify it. Okay, now again, if you look at that, that does look very messy. I'll be honest, you kind of get pretty good at it after a couple reps, and you actually do kind of memorize it. But it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we're going to be dealing with the real solutions of this today. Now, luckily, I will not make you derive this and show you where this comes from. It's really messy. You don't want to do that. Okay, so let's try to see what this looks like. For instance, I'm going to give equations that look like this. We want to find the zeros of f of x equals x squared minus 6x minus 11. Now somebody asked a great question earlier. They go, why can't we just do what we've been doing? Well, on a problem like this, there are no two numbers that multiply to get negative 11 and add to get negative 6 that are integers. Okay, now if you can use the shortcut, by all means, use the shortcut. If you can't, you have to use quadratic formula. So what happens here is I find out what are A, B, and C. For instance, A equals 1, B equals negative 6, C equals 11, or negative 11. And you plug each part in. So I plug negative 6 in for B, I plug 1 in for A, and I plug negative 11 in for C. And then I just simplify. So I simplify everything down. Now if you can get to this part right here, you are doing just fine. I'm going to challenge you to try and simplify that down by simplifying radicals and get a more precise answer, which would be something like this. Okay? But if you can get to this part right here, you are just fine with what we're doing. Again, I would like to challenge some of you to simplify further, and we will talk about that. But it's really not that bad. It's simplifying radicals, which we've been doing, and then simplifying fractions, which we can do. Okay. So again, the method of this is really going to be plug and chug. That's what we do. So number 1 here, it's kind of got the steps drawn out for us. I want to find the zeros of each function using the quadratic formula. So I have f of x equals x squared plus x minus 1. And now I want to set them equal to 0. So set it equal to 0. Okay. When I look at that here, I need to find what is A, B, and C. What is A in this equation, Jarrett? A is?
1.
B is? Jarrett?
1.
No, B is?
1.
C is? Negative 1. So A is 1, B is 1, C is negative 1. Okay? I'm going to take each part of that and now plug it in. So I'm going to plug 1 in for A, where my A values are. So 1 goes in for my A values. I plug 1 in for my B values. And I plug negative 1 in for my C values. Okay. So I get negative, parentheses 1, plus or minus, square root of 1 squared minus 4 times 1 times negative 1, all over 2 times 1. So I plug everything in, and now I chug through my simplification. So as I simplify this, I'm going to get x equals -1 plus or minus. 1 squared gets me 1. -4 times 1 times -1 gets me a +4. All over 2 times 1 is actually 2. We good so far? Plugging all that in. And then I just simplify what's underneath my radical. X equals -1 plus or minus. 1 plus 5 gives me the square root of, 1 plus 4 gives me the square root of 5. All over 2. Now I'm at this step right here. Yes, sir?
Where do you get the 1?
Which one? This one? B right here. So that's negative B, so I have B. If this were like a negative, then this would then turn to be a positive because it's 2 negatives. Okay, good question. Now I get this part right here. Can I simplify the square root of 5? No, I cannot simplify the square root of 5. This is actually my answer on the problem like this. If you cannot simplify the radical or cannot simplify the fraction, that is your answer. Okay, yes, sir?
Would it look any different if you could, or would it just be the number in the square root spot?
It will look a little bit different, and I'll show you what that looks like on this next problem, actually. We will simplify the next one a little bit further. Okay? Number 2 now. Let's try number 2. F of x equals x squared minus 6x plus 6. I always want to set everything equal to 0. So really this is 0 equals x squared minus 6x plus 6. A equals what here, Sage? A is 1. B is what, Reagan?
-6.
And C is what, Garrett?
6.
Okay. So I find my values, and now I plug each value in, giving me x equals negative, parentheses, -6, plus or minus the square root of -6 squared minus 4 times 1 times 6 all over 2 times 1. Okay, so I took each value, I took 1 for A and I plugged it in. I took -6 for B and I plugged it in. And then I took 6 for C and I plugged that part in as well. Questions on where my values got plugged into there? Now I simplify. 2 negatives out front get me a positive. Negative, 2 negative, I got -6. 2 negatives give me a positive there. Plus or minus the square root of -6 squared is 36. -4 times 1 times 6 is -24. All over 2. So I simplify here. Simplify that radical. 36 minus 24 is actually 12. So I get 6 plus or minus the square root of 12 all over 2. Are we good with where we're at right now? Okay. If you can get to this part right here, you are doing great. Now I'm going to challenge you to simplify this further. I'm actually going to erase the left side so I can work through this. Okay, I'm going to erase this side over here. So right here I have x equals 6 plus or minus square root of 12 over 2. I can simplify the radical square root of 12. How does the square root of 12 simplify? Anybody? 4 and 3, right? It's the square root of 4, the square root of 3. The square root of 4 is actually 2. So this becomes x equals 6 plus or minus 2 square root of 3 all over 2. Okay, all I did right there is I simplified the square root of 12. I simplified the radical. We know how to simplify radicals. We're getting really good at it. Now I just have a fraction there. I can simplify the fraction, actually. And I get a final answer of x equals, what's 6 divided by 2? 3. Plus or minus, what's 2 divided by 2? 1 square root of 3. So x equals 3 plus or minus 1 square root of 3. Now, do I really need that 1 there? No, I don't really need that 1 there. I just kind of showed it there right now so you see it. But really my final answer would be x equals 3 plus or minus square root of 3, and that is it. Then if I really want to be more precise, I could use a calculator, find out square root of 3, throw that in there, and I'll get exact decimal answers on that. Okay, how are we doing? Doing well? Good. Feel like you can try one on your own? Okay, try number 3. I will let you use a calculator on this. Try number 3 and 4 with a calculator, just because you do get some higher numbers with some of these quadratics and such. So grab one if you need one. All right, a lot of us have done a great job on this looking around. When you work it all out here, you plug everything in, you actually come out with negative 23 plus or minus the square root of 49 all over 6, which is really negative 23 plus or minus 7 all over 6. And everybody's right there and we're doing really good. Now, well, where do our two answers come from? You have that plus or minus. You do each of them. So for instance, I'm going to say negative 23 plus 7. What's negative 23 plus 7? I get negative 16 over 6, which is really just negative 8/3. And then I do, change my color up here. Then I do negative 23 minus 7, which is negative 30 divided by 6, and I get negative 5. And now I actually get my two solutions. Yep. Okay, so those two exact answers come from, I take the plus and the minus. That's where the plus or minus comes from. Negative 23 plus 7 divided by 6. Negative 23 minus 7 divided by 6. And now I got my two exact answers. Okay, now let's look at number 4. What do you notice about number 4? What's different about this one? It doesn't equal 0. So I have to move either one thing or I have to move two things. It doesn't matter which way you go. You're going to actually get the same exact answer. Which way would you want to go to set equal to 0, Sage? That's probably less work. I would agree with that. So let's move the 4x squared. So I'd get negative 4x squared. So that gives me 0 equals negative 4x squared plus 8x minus 3. And I would work that one out from there. Try that one. As you're working it out, I believe you get something like x equals negative 8. Oops. Plus or minus 4 all over, is it negative 8? Is that right? Okay. So when you work that all out, you get negative 8 plus or minus 4 all over negative 8. And now I would do both the plus and the minus to get my more exact answers. And when I do both of those, what do I get? John, you think you got it? So let's do this part. What's negative 8 plus 4? Negative 4 over negative 8 is actually? Huh? Negative 4 over negative 8. Simplify it. Other way around. Half? I get a half? And then I do the other part. Then now I do, change my highlighter up. Negative 8 minus 4 all over negative 8. And that gets me, what'd you get, Reagan? Yeah, right there. The second part.
3 over 2.
3 over 2. Nice job.
So you just ignore the negative?
Because the two negatives cancel each other out, so it's positive.
Okay.
That's why.
Oh, yeah.
Do you see that? Yeah, sure. How are we feeling about this? Good? Okay. Again, when you get something like this where your radical can simplify, you're just fine if that is your answer. If we are feeling good and great like I think we are, here's your assignment.